So, my name is Vlad Neykov, and as the slide here says, I'm here to talk to you about the VFX Graph. We did come out of we did announce coming into preview a year ago to Unite LA, so it has been quite an eventful year for us. Just to kind of get a sense of how many of you have had a chance to work with the VFX Graph to cater the talk a little bit better, can you raise your hand if you have already tried the VFX Graph? Okay, so it's roughly about half of you. So I'll also mention a few basics. We do have a lot of materials that became available, but the focus really will be to give you a good overview, maybe point you in the direction if you want to get started, and really show you what the VFX Graph is capable of. And for those of you who have tried it already, I would like to talk a little bit in a live demo about some of the new features that we've added. So without further ado, I put together a little trailer of some of the things we've used the VFX Graph with in production internally during the past year. So we have been quite busy. A quick overview. The VFX Graph is a next-generation visual effects tool for Unity. I like to think of you as something that goes a little bit beyond just making particles. As you saw with some of these demos, and we're going to go into more details later, it can be used for different kinds of complex simulations. It is a self-contained template asset. It lives in the project folder as an actual asset, and it has event and parameter interfaces that allows it to communicate with the rest of Unity. Integration with timeline, you can access it via script, through the inspector, etc. It is also designed to work with the script that run the pipelines, both HDRP and Universal. And as you've seen this Unite, there's been a lot of talk about both of them. And it is also tailored for next-generation devices. So the VFX Graph is generating compute shaders, so it runs on compute-capable devices. Down the road, we do want to support also other devices. We'd like to have an option to have also CPU particles. But for right now, the VFX Graph is very much GPU particles. And let's just quickly kind of explain the difference between them. On the left side, we have the built-in particle system within Unity that many of you are probably familiar with. And on the right side, we have the VFX Graph. So there are pros and cons to both systems. The most obvious one is particle count. Because we are running the VFX Graph on the GPU, that allows us to simulate significantly more particles without dropping frame rate. So as opposed to CPU, we can usually do about thousands of particles. In the GPU, we can simulate millions of particles. The simulation itself is also more complex. As I mentioned, we're not talking just about a particle system. You can actually drive different simulations that go beyond that. So the VFX Graph allows you to really construct a lot more complicated effects. Now, a slight drawback, however, is that because the VFX Graph is operating on the GPU, that means that we don't really communicate too much with CPU land, in this case with the physics system. So while the built-in particle system can do things like world collisions, within the GPU system, we really have to do certain scene representations. So we can do collisions with different primitives that you have to kind of set manually. We can do collisions with a depth buffer, and you can also bake sign distance fields and collide with those. So it takes a little bit extra effort to make the collisions work the way you want them. But it is still very much doable. And the other thing is gameplay readback. Within the built-in system, you can query what particle number 2 is doing, what its color is, what its position is. But in GPU land, we don't have this right now. We do plan eventually to add some more communication between the two, but that brings us really to the issue with latency here, because it is more expensive to read data from the GPU back to the CPU. However, another big bonus for GPU for us is that we already have access to all the frame buffers, so we can read the color, the depth buffer, and we can do some really cool effects with that. I'm not going to go into too many details. Again, there's been a lot of materials already online that explain, and I'll show at the very end a few links that can help you get started. But just as a very rough overview, so everybody's on the same page, we have these, what we call contextual nodes. And there's a few more, but these are the more basic ones that are the building blocks of any effect. Within spawn, this is the block that determines how many particles will be spawned that frame. The next one in initialize, within this contextual node, think of it more as the start function in C#. You will just set the initial values of your particles here. This is also where you can actually specify the capacity of your system. So you can say that if it's a small effect, you don't really need to reserve a lot of memory for it. And of course, if it's a large effect, in this case, the default is 128 particles. I mentioned we can go up to millions. So make sure you change that number if you want to see impressive number of particles. Also, the bounds are here. So the bounding box is not dynamic, unlike the built-in system, which, again, we can detect where every particle is and dynamically resize it. You have to be a little bit more proactive here to decide what is going to be the bounding box, because if your camera is not viewing that box, the effect will just disappear. So if you have a very large effect and a very small box, and that box is not within the camera frustum, the effect will not appear. So make sure you modify that. Then we go into update. Update is really just like update within C#. It runs every frame, and this is a great place to do things like collision simulations, maybe add different like noise, turbulence, etc. And then we have the output, which really determines how particles are rendered. The really cool thing, though, is it goes a little bit beyond just rendering. You could set the size in output as well. So the way it goes is, usually the flow goes from top to bottom, but between update and output, it's a one-way street. So you can change a value in output, and then basically it's going to receive the next frame a new value from update. So if you don't, for example, need to change the size throughout the whole graph, you can literally just set it at the end, and this way you're not going to reserve a buffer for it. Things, of course, can get a lot more complicated after that. So this is a medium-sized graph. Of course, if you see the graph for the antagonist from the Heretic short film, Morgan, it is about 10 times the size of this. And the point here I want to make is that this tool really has a lot of extensibility, and you can do some really, really powerful effects. In point in case, there's going to be a link at the end that will give you access to the samples. We have created a bunch of internal demos. Some of them we've kind of cleaned up and commented out so people can learn from them. So I do encourage you to check those out. In addition, we've done this spaceship demo, which is also available for everybody to download. There is going to be, again, a link at the end of the presentation with a very, very nicely written blog post by my colleague Thomas Isch that describes really the whole workflow within that. You saw the Heretic during the keynote. We have used it also for the dust simulation, some smaller effects, and of course the big antagonist at the end, Morgan. And a bit of a more brighter colored project. The visual effects graph doesn't have to be just for explosions and destruction. We have the short film Sherman, all the water simulation, well, there's some explosions, but they're dirt and rocks. But anyway, so we've done this as well, electricity, etc. So I'd like to just touch a little bit on the technical side of how it works. So we have, this is the icon for the visual effects graph, you have your actual asset in the project folder. And this contains scriptable objects as sub-assets. This is the user-facing side, so what we saw before with spawn, initialize, update, all the nodes, all the blocks you add to that. So this is what a user sees. What we do from this, though, is we generate an expression graph, which is a lower-level representation of the visual effects graph. So at this point, things get a little bit more efficient. And from there, we send everything to the visual effects compiler, which generates a lot of runtime data. The kind of data we have includes shaders, of course, and these come with compute shaders, which we use for the simulation, and that's what I mentioned, the platform dependency that you need to run the visual effects graph on a platform that supports compute shaders. And we also do vertex pixel shader pairs for the visuals. We also do bytecode for the visual effects CPU interpreter. Some things are more efficient actually to just calculate once per frame on the CPU than once for each particle. So for example, things like time. There's no need for us to calculate it a million times for all your particles. We can just do it once. And we also do some constant folding. So for example, if you have a variable that is sort of internal, maybe size, you set size to be 5, but at no point are you changing that, then we're going to replace that variable with just the number 5. So it makes things a little bit more efficient. And speaking about efficiency, we also have this particle data layout. So each system only keeps the data that it needs. So for example, if you're not using velocity in your system, we're not going to store per particle another vector 3 for the velocity. So the system is really optimized in a way that allows us to really just get you what you need and not really bloat it up with anything else. So you might see some complex effect, and of course this will be a little bit heavier per particle. But if you need a simple effect, it's not going to carry all this bloatedness of the larger effect with it. We also have a property sheet. This is basically where all the exposed parameters are kept. These are things that you can access via timeline, via code, or modify them in the inspector. And at the end of the day, we also have a list of the visual effects systems, which basically binds everything together, and we can issue different calls to all of them. I promise that was the most technical slide I have. So a little bit more user-facing, we have 2 types of compiled data. When you are editing an effect, we have the edit time. It's really convenient because unless you're changing the underlying structure, you're adding new blocks, you're adding new outputs, etc., then you can modify a visual effects graph in runtime, even in play mode, without having to recompile. So it really, really speeds up iteration time. You create an effect, and maybe you want to see how it looks with different color, different sizes. You can change the speed values, all of these things. Again, as long as you're not adding new scriptable objects to it, then you can literally just see it in real time and modify it. We also have additional debug and profiling data. You can basically check and see what kind of code is being output. So edit time is sort of the less optimized but really more user-friendly version to work with. However, once you actually build a player with this, then we go to the runtime data. This is optimized. We do the constant folding that I mentioned, and we also constantly, the constants are directly injected in the shaders. So we don't keep this usability side as something that you pay for in terms of performance later. Once you ship a product, it is as optimized as we can make it. So this is now we're getting to the more interesting parts. We have added a bunch of new features this year. Subgraphs, they're absolutely essential for making larger projects, larger visual effects, but also they really allow you to extend the kind of library that we ship with. So on the one hand, subgraphs are great for just organizing your things. Maybe you have some really complex behavior, similar how Shader Graph is using subgraphs and other tools, and it allows you to just compact things. But also, subgraphs are available in the contextual menu, so when you search for a node, you can also create things that you yourself use a lot. So we don't need to ship for everybody's use case. You can extend the library by just creating some simple subgraphs, and I'll show some examples of this in a little bit. Also, it's still a little bit experimental, but we added the first pass for the Shader Graph integration. This is really, really powerful because for anyone who had used the visual effect graph in the past, you know that you're sort of bound by the outputs that we supply it with. And if any of you, actually, has anyone tried to modify an output within the visual effects graph? Exactly, nobody. It involves modifying about 5 shader files and 1 C# script. So now you can use Shader Graph. You can create your own look, and you can expose parameters in Blackboard, and then you can assign it to your visual effects output, and then all these exposed parameters will be available. And again, the demo that I'm going to show in a little bit will demonstrate that. We also added the first iteration of particle strips. This is basically the ability to add trails, ribbons, beams, so long stretchy particles that are connected with each other. There's another small feature, somebody asked me about this yesterday. We have the ability to spawn in sort of these periodic bursts, but there's certain cases that it doesn't address, and the per spawner loop and delay allows you to basically say how many times does the system trigger, is there a delay before it, is there a delay after it, how long are the individual trigger times going to last, etc. So it allows you to time effects a lot better. And last but not least, we added motion vector support, which gives you nice blurriness, especially for things like sparks and things that move really fast. And that's really just activated by a checkbox. Right, so we're going to go into a live demo on a laptop, because that's always a great idea. I'm just going to quickly switch here from my... Oh, I unplugged everything. So the live demo is going to show a couple of things. I would like to demonstrate these effects that we discussed here, but also maybe just to give you a more familiar understanding of how we can actually function with the Visual Effects Graph. So unplugging the cable was not the best idea I've ever done, so let's switch here. Right. So I've opened a bunch of windows here. The first thing I'd like to start with is discuss the shader graph integration, just so I can actually switch this around. And let's see. And if maybe somebody from the technical side can come and see why the thing is not showing on the screen, I'd appreciate that. Or I can be very descriptive with my words. So what we see here... Ah, there we go. You intimidated it into working. I appreciate this, good sir. So we just need the resolution to change again. Right, so I'll play it at the very end, just because entering play mode takes a little bit longer. But I've created here a simple effect with some pages, basically, that are going to be burned, not in any censorship kind of way, but in the magic book kind of way. And I have also a shader graph that is customized to do what is commonly known as alpha erosion. This is where you can basically kind of make things burn out a little bit and add a little bit of layers to it. And in addition to that, I've added motion vectors to them. So at the end of the presentation, I can enter play mode, and if everything goes all right, you can see how it adds a little bit of blur to them as well. What also is really powerful here is that because the shader graph integration works so well, we can also change things in real time. I will encourage you maybe to do this on your own free time, just so I don't compile shaders here in front of everybody. But let's dive in. So on the lower right side here, you can see the shader graph shader. It's not terribly complex as such. We are looking at this output node that got added specifically for the Visual Effects Graph. It's called Visual Effects Master. And if you are familiar with shader graph, it is really just available here within all the master nodes that you're probably already experienced with. So we have visual effect here at the bottom, and it has two modes. If you click here, there's a lit and an unlit. I am using lit right now. The only thing I'd like to mention with this, we do have error warnings for it in case you sort of forget this step, is we have lit and unlit outputs within the Visual Effects Graph. So, of course, you need to use a lit output with a lit shader graph and an unlit output for an unlit shader graph. If you do miss that step, then, again, that's going to be a little message that will pop up and just kind of warn you about this. So, very quickly, what we have here is within the blackboard of shader graph, I've exposed all these parameters. You see here ash edge, fire edge, the albedo, so the textures, the ash color, fire color, etc. Up here, within the output, there's this new field called shader graph, and this is where you can assign specifically a shader graph authored shader that is using this visual effects output. And you can see all these things that I've mentioned here with the exposed parameter, ash edge, fire edge, albedo, etc. So all the parameters that we see over here are basically derived directly from shader graph. And this allows us to do this effect that you see on the left side. As the pages go up, I'm just moving a value over time, and technically I'm just doing alpha clipping, but I've also just modified it a little bit, so the darkness of the burn pages and the fire edge are sort of triggered a little bit before it, and everything sort of shrinks together to dissolve the page. The other thing that is really cool here is I mentioned subgraphs. I'll just give you a few examples. So I have here this page selection, which is really just a smaller subgraph that I've made. Let's see, visual effects, subgraph. So these are what we call subgraph operators, and therefore nodes. Nodes is anything that you plug in from left to right, right? So this is a combination of different nodes that I've made, similar to these. Just grab them. You can just do right-click, convert to subgraph operator. Another type that we have here, you see this here, book initialize, you can also do subgraphs with blocks. Now this is very helpful if you find yourself often doing the same sort of starting blocks for everything. Maybe for most effects that you're doing, you're always setting size, lifetime, color. Maybe that's something you always do. So if you combine these, you can literally just add it once, maybe expose what you need to modify, and that can really speed up your workflow as well. One example actually I would like to give is I often find myself personally, and maybe you're in the same position, where I need to get a random vector 3. I want to get a random position. I don't necessarily want to just get the random number, which we have here. So if I do random, this gives us one value from 0 to 1. Maybe I want to do it from -1 to 1. And then I want to duplicate that and just change the seed, so it gives me a different random value than the one before it. Then maybe I want to do it again. And then do another seed for this. It doesn't matter what it is, just as long as it's different. Then I have to go, oh well, let's append a vector, combine them all together. And at this point, we have a random vector 3 that goes from -1 to 1 for each. But then maybe I want to also have some kind of scale to it. So I do multiply, and then I give it here some other value. Like maybe this we can rename here, and maybe this will be the scale of it. Right, so this, even though it didn't take me that long, is annoying to have to do all the time. So what you can do instead is, again, you can just select these, right-click, convert to subgraph operator, and I can just save here, Magic Book, Visual Effects, Subgraphs. I can save this here as random vector 3. Right. I'll show it to you in a second. I don't want to keep going back into the book visual effect because it takes a while to recompile. The last type of subgraph I want to show here before I show the actual subgraphs is this. What we can do also as subgraphs is to actually inject actual whole effects into another effect. So here I have made separately a trail effect. You see the little swirly yellow trails that go above the book. And that is its own standalone effect here, trails, and you can literally just drag and drop an effect into another effect. This is powerful because it allows you to have a level of modularity. Let's say you often have sparks, and sparks can come from hammering an anvil, could come from explosion, maybe some spaceship terminal explodes, but you can author just once a spark effect, and then expose maybe its velocity, maybe its color, maybe how many sparks you're getting, things like that, and then you can reuse it. So this is very, very powerful because it does allow you, as I mentioned with the actual subgraphs, to build up a library. So for your projects, once you solve these issues, you don't need to solve them again. And now I'd like to show you just how the subgraphs look from within. I'll open the one that we just created, the random vector. And there are going to be a little bit of loading pauses here and there. I have a few jokes if they get too long. I'm going to close the shader graph because we went through that already, just to give a little bit extra space. Right, so this is exactly what we just converted, right? This is just what we added in the other effect. However, right now it doesn't really do anything. So what we need to do is probably we need to make sure that it outputs into something. So you see there's like a little output area here. We're just going to create a vector 3 and move it within output. Then we can name it here random vector 3. And then we drop it, and we assign it. So at this point, if I just save this, we're basically going to always get this random vector 3 from -1 to 1 per x, y, and z. However, we have here another thing, right? We have the scale. Maybe you don't want to always just get that random vector and then multiply it every single time. Maybe you want this to just be built in. So as such, I'm going to just create here a float. I'm going to call it scale. I'll make sure it is actually exposed. And then I'm going to drag it down here and give it a default value of at least 1, just to not confuse myself in the future. Add it here. And yeah, I can just save it. So as I mentioned, the cool thing is that this particular subgraph now is available in any effect that I work with. So just to show you there's no silly business here, I'm going to create a new effect, and this is actually how you create a new visual effect if you haven't done it in the past. You go to Create, Visual Effect Graph. It creates a default particle system, And then when we go inside of it, just double-click it. It will have like very similar layout than what I showed in the beginning of the presentation. And now if you want to get this randomness, we just go random vector 3. And here it is, with the scale that we exposed and with the random vector output. You can even add tooltips if you want to be fancy with it. Right. And similar with the other ones, just want to quickly show them. So we had the page selection, which I used for the book demo. I've basically just exposed seed for both the column and the row, and then I'm getting the output. And I'm using here a very, very handy note called probability sampling. You basically tell it how many entries would there be and what's the weight of each of them. So in this case, they all have a weight of 1, which means there's an equal chance that this will return either 0, 0.333, or 0.666. Just because that's how I've structured my texture. There's 3 columns and 2 rows. And the other one is the block subgraph. So it looks like this. I'm literally just setting lifetime, but I've exposed it. So within the book, I can actually modify this. Size, I've just set to 1, but I haven't touched this. And I've set just some position because it works for this effect. You can also specify where this thing can be available. So when you create these, if you do something specifically that should live in initialize and it doesn't make sense for it to live in update, you can specify this here so people will then use it in the right context. Right. Now next, let's talk about the particle strips. So this is the trail effect. You see it again on the left side here. And it is sort of, again, as I mentioned, like a first integration with it, but just to show you how to actually get it activated. We have a new data type. It's called particle strips here. You set this within initialize. If you select initialize, over here we have the actual data type. By default, it's particle, but you can switch it to the particle strips. And this is a good place to mention the use of the inspector. So the visual effects graph is very, very heavily reliant on using the inspector. A lot of blocks or contextual nodes will have parameters you can change. So whenever you set up your layout, clearly this is not very useful for everyday work. It's mainly for the presentation. But if you have a really large presence of the visual effects graph on your screen, make sure you leave some space for the inspector. Some of very common things you'll be doing here is you can set things to be random or not. You can decide whether the particle information is being inherited within this context here or being received from elsewhere. For example, you can send data via script or what we call GPU events, and this is demonstrating the GPU event here. This allows every particle to send information into another particle. It is very similar to the a sub-emitter functionality within the particle system that comes with Unity, if you're familiar with this. But it actually gives you a little bit more power because you can really inherit any kind of information, not just the one that is exposed with the built-in system. In addition, outputs very, very heavily rely also on your inspector. You can set here, if it's a lit output, for example, the kind of lighting model it's receiving. You can actually enable motion vectors here, which is, I'll show it at the very, very, very end. But if you go further down, there is literally just a checkbox, generate motion vector. This is, I don't have a good segue for this. But I'm going to say it. We talked about how both HDRP and Universal support the visual effects graph. Within Universal, we currently only support unlit shaders. There's really no technical limitation for this. We just haven't gotten around to add lit shaders. But just be aware of that. At the moment, if you want to do lit particles, you have to be within HDRP. The visual effects graph is also a dependency for HDRP. So if you do want to load it up, you literally just have to install HDRP from the package manager, and the visual effects graph will come automatically with it. We do eventually plan to have lit support as well for Universal. Again, it's more a matter of time right now. Right, so this is that. I did create another effect to demonstrate the per spawner loop and delay, and it was just this morning, and it looked terrible, so I removed it, but I'm going to show you at least the graph for it. So the idea for that, as I mentioned, is that you can really decide how things are being spawned in terms of any particular timing that your effect might require. So I originally made some debris falling from down here. It was distracting, and it didn't look good. So here's the demonstration of what it actually does. If you select the spawn contextual node itself, we've added all these new functionalities here. The loop duration is basically, as it explains, how long would this current loop last So if you have a constant spawning rate, you do maybe 2 seconds, it will spawn particles for 2 seconds, and then it will see what the rest of the graph tells it to do. The loop count, again, self-explanatory, but you can actually have now a limited number of times an effect triggers, which is also very, very powerful. And then, of course, you can set a delay before or after, and all of these can also be either a constant or a random number. Here I have a random value between them, so when this effect spawns, it'll wait 0.1 to 0.3 seconds in the beginning, and it will wait 0.1 to 0.3 seconds at the end. But as I mentioned, it looked pretty terrible, so I did not include it. So the last thing for the demo here would be the motion vectors. I'm going to go back quickly into the book effect. They are also per output, and the book effect is maybe a good or decent enough example to show that the effect that you're working with does not have to be just that one effect. So in this case, I have a separate effect for the pages, separate effect for all the sparks that are flying out. I have nested the effect for the trails that go around. There's a separate little effect for this little circle that it starts with, and there's a separate one for the light beam that's coming down. But the power of actually including them all within the same visual effects graph is that I have an event, and I can trigger this once and tell everything else to start. So in the past, especially if you've done any custom solutions with visual effects within Unity, very often you will have to write a script, or at least do some really creative timeline magic to make sure that everything triggers at the right time when you need it, when you want it. The power of doing this, especially with the addition of subgraphs and including prior effects inside here, you can literally just have an empty effect, but that empty effect is really just a control effect where you put all the effects you want to trigger, and then you just basically hook them up to the same event, so they'll start at the same time. So for motion vectors, I'll go down here. So, as I mentioned, you just have to tick a checkbox. I've included the motion vectors on the pages, right here. And it's a bit subtle, so the other one that has a little bit more of them is going to be the fire embers that fly out. And same thing, this is an unlit output in this case, but it's also generating motion vectors. So I'm going to do a very, very risky thing on a laptop. I'm going to enter play mode so you can see them in proper full effect. I'm going to maximize it on play. And then I'm going to just start rambling for a few seconds until it actually goes inside play. So I hope you've been enjoying your Unite. I hope that you didn't travel too far. I hope food has been good. I hope you're going to go and get some food after that. And Unity will crash, so I'm going to move on after this. Thank you. Thank you. So the good news, maybe this was planned, you never know. The good news is we'll clean up this effect and put it up within the samples so you can download it and check it out. I do have also pre-recorded video of that, but I think at this point I'll be cheating. So I'm going to move on with the remaining slides of the presentation, which will include links, as I promised, to all the resources. I'm going to make this full screen. So the first one is the spaceship demo. It's the blog that explains everything about it, but there is a link for you to download the whole project. Then we have the visual effects samples that I mentioned. There's usually, I think, about 10 or some effects in there that kind of cover different things. And the blog is a little bit outdated by now, but at least the basic functionality of getting started. If you have not tried the visual effects graph in the past, I do recommend checking this one out. And this is, of course, the end. Thank you very much. So I'm happy to take some questions. There's a couple of mics in the back if you want to grab these. And if you're in the front here, just shout it out and I'll repeat the question. Yes, please. Right, so the question was if this is a preview. Up until now it has been, but in 19.3, so the next release of Unity, the visual effects graph is coming out of preview. Yes? Right, so the question if we're going to provide some samples, yes, besides the link that I mentioned here, because it's a little bit more complex, we do want to actually include more beginner effects that just kind of get people started. So yes, that's the plan. Thank you. Yes? The question is how it works on mobile. As long as that mobile supports GPU, compute shaders, or GPU particles in our case. It generally works, and we have a few known issues. I believe the newest iOS had some issues, and we had a few Android issues we have to iron out. But the plan is that it will work on compute-capable devices. We're a bit in bug-fixing mode right now. Any other questions? Yes? So if a compute shader isn't available, right now you just can't use the visual effects graph. I'm going to just close this window so it doesn't look like it did crash if somebody just walks in. However, the long-term plan is to support also CPU particles within the visual effects graph. That might, don't quote me on this, but it might be also something to do with dots. I don't know yet, but we want to make it as efficient as possible, so if that is available, that will be a good option. But once we have CPU particles, we can try to get parity with the built-in particle system, and then you'll be able to do anything you can with the built-in system with the visual effects graph, but down the road. Any other questions? Yes?
One.
So the question is if you can use any kind of scripting. Right now, no, but we do plan to add some support so you can read and write data. I think there's some people with the microphones.
Yeah.
Yes?
Right here. Any specific information about the integration between the VFX graph and the shader graph?
What kind of specific information?
Like, are they going to be in a joined interface, or how are they going to interact with each other?
As I just demonstrated, you basically would create a shader graph with a visual effects output.
Right.
And as soon as you have something exposed in Blackboard, you just assign that asset within the visual effects graph output, and everything will become available.
Oh, I see. Thank you.
Awesome. You sound like the voice of God. I can't see with the lights here. Any other questions? Awesome. Thank you so much for your time. You can grab me after this if you have any other questions.